previous talk, so if you weren't in the room for it, I'm not going to cover anything with you today. So I'm just going to tell you a little bit about me, so you get some framing information and some background. Now going into what Aquilon is, give you a convoluted and vague example of how to use it for things, and then wrap up. So I work at the Science and Technology Facilities Council in the UK, in the Scientific Computing Department. I think we're one of the largest scientific computing departments in the world, with about 160 staff. We run lots of big things, supercomputers, high throughput computing, high performance computing, a couple of supercomputers in the top 500. They're worth 3, but we've got them lots more. I've personally spent about 7 years working on with primarily the large hadron collider. So I started as hardware planners, working out the middleware, and now I'm designing deployment and installation systems for the whole service. That's my perspective. I realise this is an APC room, so I'll try and make it bigger way to see as I go along, but I might be lying. So this has told you about Quattor and what we've had so far. So it originated from the woodwork. It originated with most of the development work being done at CERN. Wasn't a funded project.
Can I ask you to speak up?
Sure. I'll do my best.
Thanks.
I'll just talk louder and louder and louder until you tell me not to. So most of the original development work for Quattor was done at CERN. They came up with an original configuration management system called SCDB. As far as I can work out, C stands for CBS, because that's what the configuration code was stored in. It was integrated with some of the production systems at CERN doing inventory and deployment. Tried to get used by other people in the community, quickly abandoned it and replaced it with something called SCDB, but it stands for subversion. You can see the pattern version here. There was no inventory system package with it at all. It's just some anti-tasks that we introduced to run stuff to hosts, and some of the infrastructure that Louise mentioned earlier. Both of these had scaling issues. So CERN have recently moved away and have switched to Puppet. Some of their workflows involved, I believe, something like a 2-hour wait for a deploy for a change to go out. I think Louise experienced this firsthand at some point.
Something like that.
Quite honestly, if you're going to be doing that sort of thing, yeah, something really terrible. SCDB is what we're running in production at the Tier 1 in London Appleton Laboratory. We've got about 2,500 hosts in it now, and if you want to make things to all, it's about 25 minutes, which is starting to become a scaling issue for us. But both of those systems have similar programs. You code, compile, commit, deploy, repeat, or in some people's cases you code, compile, it doesn't compile, code, compile, it doesn't compile. Go around that circle until someone goes and fixes your problems for you. As I said, neither of them is much more than an environment for writing pan code in and pushing it out to hosts. There's some layout guidelines from the community, in particular the QWG template framework, which was an effort to try and share configuration, and still is an ongoing effort to share configuration between grid sites in Europe. It's a really great way of getting up started and running, but the lack of any rules or enforced rules for structuring and configuration leads to everyone on the site doing things in a different way. Every site does it differently, and admins within a site do it differently, because of course there's more than one way of doing it right. But what you don't want is one code base with 7 different right ways of doing something. What you want is everyone following the same coding guidelines. Now, coders understand working to coding guidelines. SysAdmins, at large, in my experience, do not. They find something that works and go with it. So this gets really, really messy. If you start deploying thousands of hosts, you're not going to want to write the code for each host individually, even if it is, this is a host that does this, it has this IP address, and that's all. It gets really boring. So then what's happening next is every single site designed its own inventory database, and some scripts to write the code from that. And again, we ended up with a fragmented community. Now, these are not huge problems. This is still a very powerful system, and everyone was still, and still is, mostly using this, and it's good enough. It's great, it does the job, it's supposed to. But, in 2007, the bank, Morgan Stanley, which Louise alluded to, turned up at one of the community meetings and announced they wanted to deploy 20,000 hosts. Everyone reeled in horror at this because we knew our systems wouldn't scale. And then they added loads of more requirements on top of this. So some of them up there, including giving it to people who aren't even SysAdmins, their frontline support staff. As in, they sit on a telephone at a help desk somewhere, someone tells them there's a problem and they need to make a complex configuration change. Editing pan code is not going to do this. You need experts involved to do that. Obviously, all of us, if we want to branch configuration, using Subversion or CBS, never do that. Branch it, might not be able to merge it back ever again. And if you're going to start spreading it around hundreds of people, you're going to need to provide and enforce a structure for the configuration. So we required something entirely new, which is where Aquilon came in. So SCDB was the first generation and SCDB was the second generation. This makes Aquilon the third generation of configuration management database for Quattor. So it is part of Quattor, which is not a separate thing to Quattor, it is a subcomponent. It does incorporate many ideas from both CDB and SCDB. It re-implements some of the things that SCDB dropped from CDB. It also incorporates things from Morgan Stanley's previous configuration management system that they designed in the 90s, which was not designed for Linux at all. It was designed for a few hundred Unix boxes. And luckily for the community, Morgan Stanley did most of the development work, which has been great. They've released everything under the Apache 2 license and is now part of the project as normal. The first impressions we got were Git. Wonderful. Git is everything we always wanted. Proper branching, proper merging, we can do development without breaking our production systems, which is great. Also, we can give it to new people and they can do development and learning without breaking our production systems. The next thing we decided or discovered was that there's no longer some code, a compiler, and a web server, and it gets pushed out to systems. There's now this thing called a broker, whatever that is. It's a daemon that owns parts of the configuration and writes code for you, which is terrifying the first time you see it. And there's a command line with documented commands and man pages. This was shocking. So the architecture is the little box that you saw on Lisa's diagram if you were to talk, which is actually conceptually quite simple, especially when you can see it without all the rest of the mess around it. The two purple bits at the top are the user-facing processes, so Git on the right, the AQ client, command line client on the left. That is your entire interaction with the system. You write code, you commit it to Git, you ask the broker to do things using client. So when this ends up in something called AQDB, which is a relational database of your choice, but there's only two that we support. It triggers the add to compile, it triggers pan, it does all the build stuff and goes out to web servers before. But now you actually have an interface for dealing with it. So this makes things really powerful. The broker really is the source of all power. It provides the workflow engine you're missing. It writes you pan code for your objects and relationships. Now I'll go on to what an object is in a minute. It owns the Git repositories, and you ask it to do things on your behalf. So, for example, if you want to do some work on a branch, you ask the broker to create you a branch. That will then get phoned out in a thing called a sandbox where you can work on it. You can then attach your hosts, or some of your hosts, just for testing, to your sandbox. So you can now work in a completely isolated environment away from your production systems. You can throw that away at the end if you want to. The broker itself is written in Python, it's using SQL Alchemy, which is the most awesome ORM I've ever come across. As I said, you have a choice of database system, but we only support Postgres and Oracle, because those are the only ones we're making upgrades for this one. And it has a kind of REST-ish API, which is useful if you want to query things. Most of the time, we would recommend using command line arrow. So I talked about sandboxing just a minute ago, but they're really, really easy to create, really lightweight. They just get a branch that you ask the broker to do it for you. So you use the AQ command. So, for example, I create a sandbox called New Awesomeness because I always implement New Awesomeness. And it gets cloned by the client and set up for you. You can just CD into it and start working. When you're finished, or when you want someone else to look at it, you cover it again upstream code review. Because we're in Git. We want code review. We are SysAdmins, we want people to tell us what we've done is wrong, don't we? Yes, absolutely. Then when everyone's happy with it, we merge it back into production. Now, you'll notice on the source here, it has my name before the production merge. This is because, really, someone else should be merging your sandbox back into production, not you. Once someone is happy with it and reviewed it, they should merge your sandbox into production. So, in this case, I'm merging mine back into production because I'm forgotten and this earlier. So Quattor has always been about modeling your infrastructure and your configuration in code. Luis alluded to the fact that sometimes this gets messy and unstructured. So Aquilon actually provides parts of your infrastructure as objects. These are then stored in the database. You can change relationships between them, but things like buildings, rooms, racks, desks, machines, switches, routes, gateways, these can all be defined using a command line, linked together using a client. The broker then writes the actual pan code for you. You never see it, it's hidden behind the scenes, it's just fed to the compiler at compile time, and everything happens as if by magic. It also implements a few structures for actual configuration. So features which are just blocks of pan code, in fact, as the broker sees them, they're pointed to something you write. It has to be self-contained, it can include other things, and at this point we'll just back into the Quattor manager pan code. Personalities is what a machine has. So one machine has one personality. And it's just a collection of features. So you have a web server which requires DNS, HTTPD, PHP perhaps, 3 different features, make one personality called web server, which is what we say is a web server. But that's personal to our site. And the host is just a machine, plus its host name, plus its IP address, a personality, and what operating system it runs. So the whole thing is still designed to be OS version agnostic. So we run a scary number of different versions, point releases of Scientific Linux in production with the same configuration tree, because most things that need to be abstracted are abstracted away, things that don't aren't. The command line provides an add, a delete, and an update command for all of these objects, and there's a huge help page. I'm not even going to show you it unless we do a demo after this talk. The next part of the model is services, which is just the concept of a service, the fact that you have servers and clients. But you want to keep track of them, you want to link them with each other. And the real power comes from these things called service maps. So you might have, for example, multiple services of the same type, that different types of hosts are interconnected. So you can define rules based on which ones match which hosts. And I'll give you a convoluted and slightly made up example in a second. But at the moment you can create those rules based on what organization it is, what physical location it has, and what network it is. When we say network IP address, what we mean is the network root IP, so whatever it is, /21 or something, for example. So you can allocate a service to a subnet. So, for example, you have 2 clusters. Both have 2 different types of compute node, but each has an NFS server, perhaps serving software to the cluster, which has exactly the same personality because they're just NFS servers. But each is in a separate subnet. What you could do is define an NFS service with an instance for each cluster. It's just that simple. Add a server to each instance. Again, everything's simple. This assumes these servers are already set up in the configuration system. Add the requirement for NFS to both of those compute node personalities. So that is to tell Aquilon that if you have a GPU cluster node or a Xeon Phi cluster node, they both require NFS. As in, you cannot build them without NFS. This is not a valid configuration of those. And then we say, to get those different servers on those instances, these are the rules for which gets which. So if it's in one network, it gets one. If it's in the other network, it gets the other. Hopefully that makes sense. So do a demo. So at tier 1, we were the first site to try and run my background with understanding. Partly this was because their Unix dev team is based in London. We're based in Oxfordshire. It's just down the railway. If that ceiling collapses, it's not my fault. So we could get their developers into our office pretty quickly, sort things out. It took about 6 months of removing all the organisms from their code to actually get anything running in the first place. We're now running with about 200 hosts, what we call pre-production, which is basically driving a private cloud at the moment, plus some alternatives like web servers just to try things out. We're still running SCDB in production. The more and more people play with Aquilon, the less and less they actually want to use SCDB anymore. It really feels painful by comparison. Waiting 10 minutes for something to compile just because you want to check it works, it's not even worth it. So we're getting very close to full migration, hopefully this year, but we're close to decided was we had a mess before, we're not going to replicate that mess again, so we're going to clean things up and move them as we go. And I think you get also doing the same thing, moving slowly and cleaning things up as we go. So, just to conclude, Aquilon is the third generation SCDB for Quattor. And at this point, as far as the community is concerned, there aren't any more CDB and SCDB gone. Keep using them, we're not going to support them. You want one, use this. It integrates with inventory information, and you can use it as an inventory database. We're not at the moment, we have a legacy inventory system. We intend to, once we migrate away from SCDB. It provides a framework and enforces it. And the broker is really the source of your ultimate power. There's also a solution to all your problems. Now, one thing I didn't mention, because you've got a broker in command line and the rest is shared by which gives you role-based access to control based on kernels. You can start driving things with other tools, and you can start developing something like a platform as a service. Because if you can say, this host is now a web server, this host is now a customer, and you can make that change in 30 seconds, and 30 seconds later you can pick up that change and reinstall itself. You start doing all sorts of funny things. That's one of the things you can do some very important things. None of which we've played with yet. So, thank you. Any questions?
Something stupid question. Configuration databases. You have different things that run the same time.
Yeah.
Or desktops. I know the answer to this is if somebody moves something, you can't find it, right?
Yes, absolutely.
But is there any mechanism that it prevents discover discrepancies within the grid?
So we have a mechanism for discovering discrepancies based on network connections. So unless we RFID tag our servers or something, I don't think we're going to know where. So we've got one, internally we have one based on OpenVP which checks that things are on the switch that's supposed to be. But yes, the answer is kill anyone, you'll be fine. So the key thing about the configuration management system, which is often overlooked, is that if you're going to do that, you need a configuration management architect who owns the whole system and is strong-willed enough to hit people on things when they do things wrong. And this person should be the person doing most of the code review and encouraging others to write good code and not move things when they're not supposed to.
Maybe the idea of RFID tagging is a good idea.
Yeah. I'm not sure how it works in a room full of methodology.
Something like that.
There's a product there, I think, maybe the Dell or something. Yep.
So, with the Aquilon system, just to clarify my understanding, the plan code is still there,
Yep.
but the sort of help desk type user you're talking about never actually sees that. They're just configuring with the sort of command line action.
Yes. I can actually give you some examples. Probably have a server I can destroy, or that no one will notice if I do destroy it because it's set up. So actually, this is the command line. And the reason I didn't want to show you the commands is there are that many commands for doing various things within the system. Each one of those has a decent help page. So I'm just going to see if I find something. Oh, I know. Any share host. No one cares about the public website. That'll be fine. So these are all the things that the public web server is made out of. So the personality is an external web server, and it has a web server daemon, and that's it. Because it's part of our site, it also gets all these various things like DNS and LVP and SysAdmin tools and the message of the day and core inputs. So every single post we have gets those. See everything about it, that it's not actually a real machine and it's in a fake building. It's not like it's somewhere. So it's currently a web server. Let's make it a nice search node. So this is the sort of thing that a help desk or even a user could have if you want to make some kind of platform as a service type thing. they're horribly wrong, but it sounds very wrong.
For the record, I didn't ask you to break things.
I think so. Hopefully that's good. Yep, so that node is now becoming an Elasticsearch node. So I should probably undo that for 20 minutes. That means the web server will probably get uninstalled for any minute, and Elasticsearch will start up and join trust. But yeah, so for a help desk user, they can do that and fix the user's problem pretty quickly. Really, they should be changing the personality of the server.
So where you've got to is you can still break things, but not for stupid reasons like syntax errors
Yes.
or what have you.
Because the compiler sits there and verifies all your profile information up front. You have that information before you've gone and broken everything. So instead of, the way I think of it, instead of moving past and breaking things, you're moving past and not breaking things, which has got to be better.
Does it support something like roles? So you can say you're a help desk user, you know?
Yes, yes. So we don't have any roles set up because we're all power users and we trust everyone, right? So the roles are based on what commands people can run. So you might not want anyone to be able to make network commands, for example, because you might have a networking team who does that. You might not want people to be able to change personalities if they're in a certain subteam, or if they're in support. But you might want them to be able to add features and remove features from existing personalities. It's up to you to define what the roles are. At the moment, they're coded in Python, so you have to put the Python module in to change the roles, but I believe that we have to put at some point soon. The development is moving scarily fast. There's a big team of developers keeping it going to more standard. We're putting local requests into them, and so that's good.
You know, there's been any work done on integrating this in Elastic Cloud, for example, Amazon?
I don't think we'll have a lot of machines. You can just treat the machines as any type of managed machines. And in terms of using it to trigger the generation of VMs, no, I don't think there has been any work there. I know that Morgan Stanley are looking at how to drive counter this. At the moment, what they've done though is focus purely on things like VMware. So they are merging a stupid number of VMware clusters and machines. So one of the concepts it has built in is the idea of a cluster of VMware machines around and there's another daemon which sits alongside that one that speaks VMware. Unfortunately, it would be a good thing to try other houses. So I think